Welcome back, students. In this class we continue circles chapter 4 exercise 4.2 fifth problem. In the previous class we completed first four problems. Here in this today's class we'll continue the fifth problem. Fifth problem given is prove that the perpendicular at the point of the contact to the tangent to a circle passes through the center. So prove that the perpendicular drawn, see this one is the perpendicular drawn at the point of the contact, means this is the line tangent and the line here, that is the perpendicular drawn to this line, so to a circle passing through the center. So this is the center. So what is the solution means, first step is, see, write the circle, then a tangent, then the line to the center of the circle. So next we'll write down, we'll start the problem. Let xy be the, so this is the tangent, so this is the tangent to the circle. So let xy be the tangent drawn at a point z. So this is the tangent xy, and at the point, so where this meets, the circle meets the tangent at this point called z. So at the point z on the circle with, so what is the center of the circle? Circle is O. So with this one, this is clear in this figure. With the center O. So with the center O. So next is to prove. Next step, we wrote what are the data here. So next is to prove perpendicular at point z passes through the center O. So perpendicular passes to the center O at the point Z. The center O. Next line, let the perpendicular passing through some other point. So we are taking, to prove this, so we have to take one more, that is, let the perpendicular passing through some other point O dash. See here, we take, this is clear in this diagram. So here, this, since this is the circle, this is the tangent, then here the perpendicular is drawn, that is through the center Z. This is x and y. Again one more, we are taking this line. So this is O and this is O dash. So let the perpendicular passing through some other point. So perpendicular is passing through some other point O dash. So we are considering one more point. Now what construction we have to write? Construction, what we did, that is, we join OZ, that is this one, OZ we did, and so, and O dash Z. So OZ and O dash Z. So after this, proof. So proof is tangent at any point of a tangent at any point of a circle is perpendicular to the radius. Tangent at any point of the circle is perpendicular. So tangent is always perpendicular to the radius. Radius through the point of contact. To the point of contact. We have to write tangent at any point of the circle is always perpendicular to this radius through the point of contact. This is the point of contact. So after this we have to take OZ is perpendicular. This OZ is perpendicular to XY, which implies that OZY. So OZY is equal to 90 degrees. So next we have to take angle O dash ZY. That is the next point. This one. OZ O dash. So O dash ZY. O dash ZY we have to consider, which is equal to 90 degrees. In the bracket we have to write, since ZO dash is perpendicular to XY. When this one is perpendicular to XY, the other is also, that is ZO dash is also perpendicular to XY when the angle O dash ZY is 90 degrees. After this, therefore O dash, so OZY is equal to O dash ZY. So this is possible. When this is possible, this when both are equal, means this line and this line is equal only when this is possible only when points O and O dash coincide. So when both the points, so this is possible only when this one is both the lines coincide. So this is the last line of the proof. Finally we have to write, finally the perpendicular at the point of contact to the tangent to a circle always passes through the center. So last line we have to write, passes through the center. So when this is possible only when the points O and O dash coincide. Finally, the perpendicular at the point of the contact to the tangent to a circle always passes through the center. So this is the solution for all these lines you have to write to prove this. So we move on to the next problem, that is the sixth one. Sixth problem is, the length of the tangent from the point A at a distance 5 centimeters from the center of the circle is 4 centimeters. Find the radius of the circle. So here a circle is the length of the tangent. So draw this circle, the length of the tangent, draw a tangent, that is the PQ. So I am PQ from the point A, from the point, that is we can take it as P, or A, B we can take. So I have written PQ from the point A at a distance 5 centimeters from the center. From here it is 5 centimeters. Next, from the center of the circle it is 4 centimeters. Now this here it is 4 centimeters. So find the radius. We have to find this one. So how much? So now what is the solution? So to the data given, first we'll write PQ is 5 centimeters and OQ 5 centimeters. OQ is 4 centimeters. PQ is 4 centimeters. OQ is 5 centimeters. I have written interchanged and written. Okay, this is 4, this is 4, and this is 5. So from this point it is to at a distance is 4 and this is 5. So here also interchange, that is PQ is 5 centimeters, OQ is 4 centimeters. This is the data given. So for this also we better to mark this one as A, then this one as B and O, then the length PQ is equal to 5 centimeters and OQ is equal to 4 centimeters. So from here, that is from Q to O, it is 4 centimeters. From P to Q, it is 5 centimeters. So this is the data. Therefore, next is in the triangle OPQ. That is OPQ. That is OP is perpendicular to PQ. OP is perpendicular to PQ. Next, in the right angled triangle, OPQ, we can take it as, so applying for this right angle triangle, applying Pythagoras theorem, OQ square is equal to OP square plus PQ square. In the bracket we can write it as by Pythagoras theorem. So next is, after this, substitute the values, that is OQ square is 4 square, OP square we have to find out, that is the radius, PQ is 5 square. So now simplify this OP square plus 25, therefore 25 minus 16 is equal to OP square, therefore OP square is equal to 9, then OP is equal to 3. Finally, therefore the radius of the circle is OP, which is equal to 3 centimeters. So just write on the circle and a tangent, then join the triangle here. So here a first circle, a tangent, from then center, that is radius, then join this triangle, then the distance between these two is given as 4 centimeters and the distance between PQ or the tangent is given as 5 centimeters. Then apply Pythagoras theorem for this right angle triangle, substitute the values and find out the radius of the circle. So this is the solution. Next we move on to the 7th one. Seventh problem is the concentric circles. Means a circle inside a circle is called concentric circles or of radii. That is, two circles are given, radii for 5 centimeters and 3 centimeters. Find the length of the chord. So find the length of the chord of the larger circle which touches the smaller circle. So this is the line which touches both the ends of the larger circle and also the small circle. So the concentric circles of radius. So this is a circle inside the another circle. These are called concentric circles C1 and C2. One, the radius is one is 3 centimeters, another is 5 centimeters. Find the length of the chord of the larger circle which touches the smaller circle. So we'll start the problem. Let C1 and C2 be two circles of radii, that is R1 is equal to 3 centimeters and R2 is equal to 5 centimeters with center, that is common center O here. Next is, so we are writing the data, that is C1 and C2 are the two circles of radii. R1 is, so R1 for the first circle, that is 3 centimeters. R2 is the radius of the second circle, that is 5 centimeters with the center O. After this, let PQ, this one, the chord means a line which touches the two ends of the circle, or for example I'll just write like this here. If this is a circle, if there is a line, if it touches the two ends in the circle, this is called as a chord. Or it may be like this also, a circle, then this one, this is also called as chord. So two arcs in the, if a line touches the two ends or two arcs of the circle, is called as a chord. So next is PQ be the chord of circle C2. So this is PQ is the chord of the circle C2. Then such that it touches the circle C2 so it touches the circle C2 at point O. So this is the point O. Next, let PQ be the tangent PQ be the tangent to the, so this PQ is chord to the circle C2, but it is a tangent to the circle C1. So PQ be the tangent to the circle C1 at the point where here R. So R is the point of contact for the tangent to the circles C1. So after this, next point is OR. Therefore OR is perpendicular to PQ. So here OR is perpendicular to PQ, because we can write it as radius is, as we studied in the previous problem, radius is perpendicular to the tangent. So we have to write a note here, radius is perpendicular to the tangent at the point of contact. So after this we have to just write PR is equal to QR. So what is PR here? These two will be equal. PR is equal to QR. So after this we have to write here perpendicular from center of the chord bisect the chord. So here bisect, perpendicular from this chord will bisect this line bisects this chord. So just write perpendicular from the center of the chord bisect the chord. So this is chord here. So next, after this, in the right angle triangle, so this line bisects PQ chord into two equal parts, or PR is equal to QR. Next is, after this line, in the right angle triangle, O or Q. So a triangle is formed here. I'll just write here. So this is the two circles. This is the chord and this is the radius. This one. This is PQ. Then this is R and this is O. That is center of the circle. So therefore, in this right angle triangle, that is O or Q, what happens? We have to apply Pythagoras theorem. So OQ square is equal to OR square plus RQ square. In the bracket, just write by or applying Pythagoras theorem. Applying Pythagoras theorem. So after this, substitute the values given. They have given OQ as 5 square is equal to, because radius, that is OQ, is this one, radius of this circle. Then OR square, OR is how much? They have given as 3 square, because two radius are given. OR is the radius of one circle, that is the small circle, and 5 square is the radius of the larger circle, that is OQ. So next is PRQ the square. So I'm substituting. So we get RQ square is equal to, that is 25 minus 9. So 25 minus 9 is equal to 16. So RQ is equal to how much? We get 4 centimeters. So after this, we are getting what? RQ as 4 centimeters. This one, RQ 4 centimeters we got. Therefore, finally, we have to write length of chord, because we have to find out the length of chord. PQ. This is the length. Here from here to here. Length of the chord PQ is equal to 2 into 2 times. So anywhere we got this distance. So this distance we got how much? That is this one. 4 centimeters we got. So 4 centimeters means this will become double. Therefore 2 into, we have to write PR. 2 into PR is equal to 2 into substitute PR, so 4. So PQ we have to calculate, therefore we got RQ here, RQ this one. Therefore 2 into PR is equal to 8 centimeters. Therefore finally, so I made a mistake here. 2 into, no, this is not, this is PQ and this is RQ. So therefore 2 into, so RQ will become PQ. So therefore we have 8 centimeters. So anywhere we know this one, PR is equal to QR. Anything we can write. Here I can write PR also or QR also, anything, because here we can write, because PR is equal to QR. So this will be one side, if we get, this will be also equal. 4 here means here we get 4. So total will be 8. So this is also correct, because we can also write QR here. Anything is correct. So this is the solution for the 7th problem. If you have any doubt, comment me, subscribe my channel. We'll continue the 8th problem in the next class. Thank you.